In this video, we are going to learn how to use sum and difference formulas to establish identities. So for each of these examples, we're going to establish the identity by working from one end of the equation to the other. So I'm going to start with cosine of alpha minus beta over sine of alpha. Sine of beta is equal to cotangent of alpha, cotangent of beta, plus 1. So in order to figure this out, I'm going to start with the side that has the sum, since the other side has no sum of angles. So the cosine of alpha minus beta identity is cosine of alpha, cosine of beta, plus sine of alpha, sine of beta, all over sine of alpha, sine of beta. Now I can see here I'll get cosine over sine, so that'll help me get cotangents. So I can divide both of these terms by sine alpha, sine beta. So I'll have cosine alpha, cosine beta over sine alpha, sine beta, plus sine alpha, sine beta, all over sine alpha, sine beta. So on the left, using that reciprocal, the quotient identity, cosine of alpha over sine alpha, that is just cotangent of alpha. Cosine of beta over sine beta is cotangent of beta. And then plus, something interesting happens. I have the sine alphas cancel, and that's how I can end up with that 1. Because I'll have sine alpha over sine alpha, which is 1, and sine beta over sine beta, which is 1. So 1 times 1 is just 1. And that's how you establish that identity. Now next, let's look at tangent of theta plus pi. We've been over this before as the periodic function that tangent is. It repeats its values every pi, so it makes sense that tangent of theta plus pi should equal this tangent of theta, since I'm just adding a period of tangent. Let's prove why this is. So we're going to use the tangent sum formula, which is tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta all over 1 minus tangent alpha tangent beta. So when I go to use this, I'll get tangent of theta plus tangent of pi all over 1 minus tangent of theta times tangent of pi. Now tangent of pi is equal to 0. So now this becomes tangent of theta plus 0 over 1 minus tangent of theta times 0. So that tangent of theta times 0 becomes 0, and up top I'm only left with tangent. So I'm left with tangent of theta over 1, which is just tangent of theta. So that proves where that identity comes from as well. So next up I have tangent of theta plus pi over 2 is equal to negative cotangent. So this is a phase shift, but equals negative cotangent. Now to prove that this is true, I want to use this formula, but I have to be very careful, because at one point I'm going to get tangent of beta, but tangents of pi over 2 is undefined. So this is not the right approach. So I have to try something different. So I'm going to think of this as the sine of theta plus pi over 2 over the cosine of theta plus pi over 2. In this way I can avoid those undefined statements, and now I can use the identities for sine and cosine for the sums of their angles. So for the sum for sine, it's going to be the sine of the first angle, which is theta, times the cosine of the second angle, which is pi over 2, then plus the cosine of the first angle times the sine of the second angle, all over the cosine of two angles added together is the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. So as I go through and evaluate this, I'm going to have sine of theta times the cosine of pi over 2, which is 0, plus the cosine of theta times the sine of pi over 2, which is 1. In the bottom I'll have the cosine of theta times the cosine of pi over 2, which is 0, plus or minus the sine of theta times the sine of pi over 2, which is 1. And this leaves me with cosine of theta over negative sine theta, which cosine of theta over sine theta is cotangent, so I'll get negative cotangent of theta because that negative is that denominator, which proves that identity. And lastly, we're going to do sine of alpha minus beta, because sometimes you may get the sum of angles for secant, cosecant, or cotangent. So here's one way to look at it. You can either memorize this identity, or you can start to think of it as, instead of thinking secant of alpha minus beta, think of it as 1 over cosine of alpha minus beta, using that reciprocal identity. And in this way, I'll get 1 over, and I'll use that same identity I used earlier, cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Now the one difference here is that now I want it to look like secants and tangents. So the way I can get tangent is if I have a sine over a cosine. So to my mind, I'm thinking if I divide this by cosine alpha, cosine beta, I'll get that tangent. But if I divide one thing by cosine alpha, cosine beta, I have to divide everything in the denominator as well as the numerator by that. And that should work out because I'll get cosine of alpha over cosine alpha, which will help me get this 1. And then I'll have 1 over cosine on my numerator, which should hopefully give me those secants. So let's divide everything by cosine alpha, cosine beta. So I'll have 1 over cosine alpha, cosine beta, all over cosine alpha, cosine beta, divided by cosine alpha, cosine beta, plus sine of alpha, sine of beta, over cosine alpha, cosine beta. So everything has been divided by those two factors. So now as I go through, I'll see that my cosine alphas and cosine betas, my lower left, get canceled. And I'll end up with 1 over cosine alpha, which is secant of alpha, 1 over cosine of beta, which is secant of beta, all over 1, because all that canceled out, plus sine of alpha over cosine alpha, which is tangent of alpha, and sine of beta over cosine of beta, which is tangent of beta. And there you go. There's the identity. And that is how you use sum and difference formulas to establish identities.